Hi everyone, today we're doing notes for 3.4, truth tables for the conditional and biconditional. So the truth table for the conditional, which is our arrow to the right, or our if-then statement, is what we're starting with. So a conditional, if, then, is only false when the antecedent, or the first part of the sentence, is true, and the consequent, or the second part of the sentence, is false. So, if P, then Q, if you have if true, then true, that's true. If true, then false, that's false. If false, then true is true. And if false, then false, that is also true. So now we have to construct the truth table for the conditional statement, if not P, then not Q. So I'm going to help you set up the top for this. So first we need to find the negation of P and the negation of Q. And then once we have those two negations, then we can do if not P, then not Q. So using what we did above, I want you to find the truth table for if not P, then not Q. Okay, first let's fill in not P. So this is false, false, true, true. Not Q would be false, true, false, true. Okay, so now we're doing if not P, then not Q. So if false, then false, that's true. If false, then true, that's true. If true, then false is false. And if true, then true is true. And then here's just a little fun fact for you. Every time you hear or utter a conditional statement, you can reverse and negate the antecedent and consequent, and the truth value will not change. And we're going to fill in a truth table for proof of this. Okay, so here we have, if you have school spirit, you will wear clothing with BGHS on it. If you don't wear clothing with BGHS on it, you do not have school spirit. So the first one, if you have school spirit, you will wear clothing with BHS on it. This is if P, then Q. Our second statement, if you don't wear clothing with BGHS on it, so that's not Q, then you do not have school spirit. That's not P. Okay, so here's where we reverse and negate. And so we're going to show that these have the same truth result. So first we need to find negation of P and negation of Q. And so let's fill those in. We have false, false, true, true for the negation of P. We have false, true, true for the negation of Q. Okay. I'm going to give you a minute to find if P, then Q, and also for you to find if not Q, then not P. So go ahead and do that, please. Okay, for if P, then Q, we're using the first two columns. So if true, then true is true. If true, then false is false. If false, then true is true. And if false, then false is true. Let's do the next one. If not Q, then not P. So that's if false, then false, which is true. If true, then false is false. If false, then true, that's true. And if true, then true is also true. And so then you can see these two columns are the same. All right, next we have to construct a truth table for this statement. So it says, if P then Q and not Q, if all of that is true, then not P. So we have multiple steps here. So let's start this one off together. So first, we need to go through and label the negations. So we have negation of P and negation of Q. So negation of P is false, false, true, true. Negation of Q is false, true, false, true. Okay, now remember we said when evaluating complicated compound statements, you want to follow kind of like the order of operations, and you start with the innermost parentheses first. So the first thing we're going to do is find if P, then Q. So let's take a minute and do this. If true, then true is true. If true, then false is false. If false, then true is true. And if false, then false is also true. Now we're going to do what's inside the brackets. And so inside the brackets, we have if P, then Q, and not Q. So if P, then Q, and not Q. So we're doing this column and this column. And we're combining these two with and, right? So if P, then Q, and not Q. So true and false is false. False and true is false. True and false is false. True and true is true. Okay, I'm going to change colors so it's a little bit easier to see this. So now this is our if statement. So I'm going to put it in brackets here. So we have if P, then Q, and not Q. If that is true, then not P. So we're actually saying if this column, then not P. And I'm going to draw the arrow like that going to the left because it's if P, then Q, and not Q, then not P. Okay, so if false, then false is true. If false, then false is true. If false, then true is true. And if true, then true is true. And if you recall, when all four of these are true, this is called a tautology. Okay, let's go on to the next one. This one says, an advertisement makes the following claim. If you use Hair Grow and apply it daily, then you will not go bald. So first we have to write this out symbolically. If you use Hair Grow and apply it daily, then you will not go bald. So we can say this, you use Hair Grow is our P, apply it daily is our Q, then you will not go bald. So we'll say go bald is R. And so then we could write this as P and Q. So if P and Q, then not R. And so let's construct our truth table. So we need the negation of R first. And so this is going to be false, true, false, true, false, true, false, true. Next, we need to find P and Q. And then our final step is the compound statement. If P and Q, then not R. Okay, I'm going to give you a minute to fill out the truth table here, and then we'll go over it. Okay, first let's do P and Q. So P and Q, we have true and true, which is true. Same thing, true. True and false is false. True and false is false. And then for all the rest of these, we have either one or two falses. So these are all going to be false. Because if you recall, the only way for and to be true is if both components are true. Okay, so now we're finding if P and Q, then not R. So this column, if P and Q, then not R. So if true then false is false. If true then true is true. If false then false is true. If false then true is true. If false then false, true. If false then true is true. If false then false is true. And if false then true is true. And our claim is if you use hair grow and apply it daily, then you will not go bald. And so here we showed this for every single case here. Okay? So now there's a part B, and this says, suppose you use hair grow, forget to apply it every day, and you go bald. So you use hair grow, so that means that P is true. You forget to apply it every day, so our Q is false. And you go bald, so that means our R is true. Under these conditions, is the claim in the advertisement false? So if we look at our table, we're looking for true, false, true. And so that is this line right here, true, false, true. And you can see here that it is true. Okay. Now the alternative way that we can do this one, if you recall, is we could also plug it into our statement. So our statement you can see is if P and Q, then not R. So you could say if P and Q, then not R. And so if we put these in, P is true and Q is false, then not R, which is true. So true and false gives us false. Not true is false, and if false then false is true. So that's the other way that we could show this. All right, the next thing we're talking about is the truth table for the biconditional, or if and only if. So we have a biconditional, which is if and only if, or sometimes you can write it if you prefer as IFF, for if and only if, is only true when the component statements have the same truth value. So it's only true if they have the same truth value. So true and true gives you true. True and true if and only if, I should say, false is false. False if and only if true is false. And false if and only if false is true. All right, so here we have to do a truth table for P or Q, if and only if, not P, if not P, then Q. So I'll help you with labeling the top, and then I'll have you fill this one out. So we know we have to find the negation of P. That we can do quickly is false, false, true, true. Then we need the first part before the if and only if. So we need P or Q. Then we need the second part, if not P, then Q. And then we're going to combine these two together and do P or Q, if and only if not P, then Q. So take a few minutes and fill out this truth table. Okay, so P or Q, if you recall, is only false if they're both false. So this is true, 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 false. If not P, then Q. So for this one, we're going from if not P, then Q. So if false, then true is true. If false, then false is true. If true, then true is true. And if true, then false, that is false. Okay, now we are looking at these two columns. And we are doing the biconditional. So remember, this is only true if they have the same truth value. So we see true with if and only if true is true. True if and only if true is true. True if and only if true is true. And false if and only if false is true. So this is another tautology. Okay, we have one more example here. And this says, consider this claim. If your super $1 million prize entry number matches the winning pre-selected number and you return the number before the deadline stated below, you will win $1 billion. Suppose that your number actually matches the winning pre-selected number. You did not return the number and you win nothing. Under these conditions, determine the claim's truth value. Okay, so let's label everything. So your super $1 million prize entry number matches. Let's call that P. So your prize entry matches is P. Then we have, you return the number before the deadline. That's going to be Q. Return before the deadline. You will win $1 billion. So that'll be our R. Okay, so now it says, suppose that your number actually matches the winning pre-selected number. So this one's going to be true. You do not return the number. So this one's Q is false. And you win nothing. So that is false. Okay, so we need to determine the claim's truth value. So if we write our claim out, it says, if your super $1 million prize entry number matches the winning pre-selected number and you return the number before the deadline stated below. So I'm going to underline this. So this is our statement. You will win $1 billion. So we have an and here, and then here's our comma splitting up the if then. So it's going to be P and Q. So if P and Q, then R. And so let's determine the truth value. P is true and Q is false. Then R is false. So let's see what happens. True and false is false. So if false, then false is what? True. So that claim is true. And that's all we have for today.